Okay.
Wings.
Yeah, it probably is. Yes.
Okay. Yeah, we're recording now. All good.
Righto.
Okay. And you saw the questions? I don't think they're.
I did. Yeah.
I don't think they're. Yeah. They're all text, so I'll just whip through them today.
Very good. Yeah. So.
Yeah. For some reason, what I'm receiving is breaking up, but it's.
Should I talk 2, 3, 5, 7, 9, 4, 8, 2?
No, I'll just bear with it. It doesn't seem to affect the recording, and Hugh said he can't hear it either. So it's got to be something at my end, which is causing the trouble.
Yeah, just hang on a minute. That's James coming in. I don't know. You probably can't hear that. I missed the call. That's all right. That's all right. I've missed so many calls today, including one. I was supposed to have a meeting with another doctor at 10 o'clock, and I waited all bloody morning. And somehow I'd missed the call. I don't know how. I thought it hadn't run. Anyway.
That happens to me a lot. Because I tend to mute my phone when I'm on the radio, and I forget to unmute it.
Yeah. Well, there's a few that I think that these are all hoary old dad jokes, but I quite like that one.
Okay,
I quite like that one.
All right. Okay, let's do the TikTok. Here we go. 3, 2, 1. Hi there, Andrew Dunkley from Space Nuts. Our next episode's coming up very soon, episode 393, and I'll be joined by Professor Fred Watson, astronomer at large, to talk about what, Fred?
Well, I was about to say, excuse me. Yes, the illness that I've had recently has obviously gone to my chest. We're going to talk about. No, that was last week. Hang on, we're going to talk about.
This is going very well.
Can we do this one again, Andrew? I'm sorry, that just caught my throat there. So,
it's all good.
Okay. I think it's part of the complaint.
Yeah, it might be. All right, we'll start again. You ready?
Start again. Yeah.
That's probably worth leaving in there. In 3, 2, 1. Hi there, Andrew Dunkley from Space Nuts. We've got episode 393 coming your way soon. I'll be joined by Professor Fred Watson, astronomer at large. What's on, Fred?
We're going to talk about probably one of the biggest questions in the universe, apart from why did the chicken cross the road? Or was it? No, which came first, the chicken or the egg? It's not that one. It's which came first, black holes or stars? Because it now looks as though galaxies are actually formed around black holes that might have been there beforehand. So a great, really, really great topic. And is it possible that Elon Musk's Starship, the largest rocket that we have at our disposal on our planet, is it possible that that could be used to ferry troops and other goods from one part of the globe to the other?
Wow, wouldn't that be something? And a bit scary when you think about it.
Exactly.
There's questions in the bag too. Somebody asking about the expansion of space. Never had that one before. Got one about the InSight mission, which has got someone a little bit confused. We'll try and fix that. And a question about gravitational waves. That's all coming up on Space Nuts. Fred, I've got a question for you myself. Why haven't aliens come to our solar system yet?
Because, it's too boring, probably.
Well, you're actually kind of right. They read the reviews. 1 star.
1 star, yes. 1 star review. That's right. Mine's even worse, I think. Where do you find the most felines in space?
Oh, no, not sure.
It's in the catmosphere.
Oh, You know, I almost said that. I'm glad.
You
I'm
should-
glad. I'm glad I didn't.
Yeah, it's pretty bad, isn't it?
All right.
Yeah. In the
Thanks,
chemistry.
Fred. It's terrible. Hope you can join us on the next episode of Space Nuts, coming to your favorite podcasting platform soon. See you then.
Yeah, that wasn't the
Lost
best.
all my paperwork.
Yeah. So, which way around do you want to do these stories?
Let's do the Black Holy one first, the Holy
right.
Moly one, because it's
Yeah,
probably
I
the
might-
biggest story. Although they're both pretty big stories.
Yeah, I might just find. Here we are. Yeah, might find the other one as well.
Okay.
All right.
All right. Here we go. In 3, 2, 1. Hello again. Thank you for joining us on Space Nuts, the astronomy and space science podcast. My name is Andrew Dunkley, your host, and we'll be chatting about a lot of things today. What came first, the chicken or the egg? Or let's be more specific, the black hole or the star? That is the question. And it looks like the answer might be a little bit of a flip on what we've always believed. We'll also be looking at SpaceX. Of course, they've been working on their latest set of rockets, the SpaceX rockets. They've got one called Starship that's in the testing phase, but they've got plans for an even bigger one. And the news is it could have military applications. What does that mean, I wonder? We will also be answering questions about the expansion of space again, the InSight mission and gravitational waves. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as always, Professor Fred Watson, astronomer at large. Hi, Fred.
Hello, Andrew. Very good to see you again.
Good to see you too, up and about. You've been in the wars lately. You found out what bit you the other day.
Yeah. Yes, that's right. It was a tick.
Tick.
A tick, a little tiny insect, and we know that ticks they abound in this district. People sometimes say the northern beaches of Sydney are the tick capital of New South Wales. I knew that. And in fact, I thought it was a tick bite. But then when I started getting other lumps appearing and getting fevers and starting to get really, really crook, I thought it can't have been a tick, but that's what it was. I've had something called rickettsia.
That doesn't sound nice at all.
No, otherwise known as spotty fever, apparently.
Oh, how horrible!
Yeah.
Well, at least they've figured it out, Fred. That's the main thing.
Yep, they did. Took a couple of people about half an hour to work it out. That's good.
Yeah. I remember when I was a kid, we went on holidays up to a place called Blackhead, which is a beautiful little beach area. Used to be a sleepy village. Now it's probably now been commercialised beyond help.
Yes,
but we used to go down to the lagoon and catch fish and, go in and out of the bush and the mangroves and all that. And one night, my friend, we were staying at his place, lifted his shirt up and there was a tick buried deep into his abdomen. I mean, it was right in there. Oh, horrible.
Yep.
Horrible things they are. They got it out with, methylated spirits.
That's right. To cool it, you try and freeze it. So it becomes inactive. That's right.
Yeah.
Anyway.
Well, it backed out in an awful hurry once that stuff was on it. But
so that was okay. That's something to bear in mind. Since I do have some methylated spirits.
Yeah. Anyway, I'm glad you're on the mend. That's the good news. Now
I am. Yeah.
Yeah. Let's get on to our first story. This is big news, and not surprisingly, comes from data collected by the James Webb Space Telescope. And it's looking into the early universe, and we've been getting questions about this from our audience because a couple of people have come in and said, look, it doesn't add up. The age of the universe doesn't correlate with those early galaxies. It doesn't make sense. Something else must have happened. And now they've actually been looking into this, and it looks like our audience members who've brought this up are on the money. It looks it hasn't been absolutely utterly confirmed yet, but if they're right, this really turns things around in terms of the early universe, doesn't it?
Absolutely. And I think it's a great credit to our listeners and viewers that they do ask questions that are also occupying, the scientists who are really looking at the history of the early universe. And what's done this is the James Webb Telescope. The fact that, yes, we have observed galaxies which are, we see them as they were when the universe was less than 400 million years old, remembering that it's 13.8 billion years is the age of the universe. That comes from really reliable observations and theoretical background. It's very hard to push it back any further, even though, as you and I have spoken about, some scientists have tried to do that and say, well, the universe must be older. But that's not what the majority of scientists believe. We are pretty hooked on the 13.8 billion year age of the universe. So the problem then is, you see these galaxies which are, they've got supermassive black holes at their centers and are relatively mature. And so how are these, we didn't think we could get galaxies looking like that with a supermassive black hole at the middle within the first few 100 million years of the universe. So how do you reconcile these? And I think the bottom line is sort of what you've already hinted at. We have tended to draw the inference that black holes generally, and particularly supermassive black holes, are products of the centers of galaxies where there's a richness of stars. And because there are all those stars there, the black holes gobble them up and they become supermassive. But that takes time. And what this new work is doing, and it's being led by some people I know, actually, Johns Hopkins University and in the Sorbonne in France, Johns Hopkins, of course, in Baltimore. What they've done is they've turned that picture on its head, which is to say, well, maybe the black holes came first. And so what they're suggesting is that black holes, and probably big black holes as well, really were formed with the Big Bang itself. So rather than black holes not being there when galaxies form and then accumulating their mass by gobbling up stars after stars are formed. After galaxies have been formed. Rather than that, they're turning it on its head. So it's actually quite subtle facts, though. So what you've got to imagine is a universe that creates black holes. Now, even people like Hawking were talking about the possibility of primordial black holes that are created within the aftermath of the Big Bang. And maybe we're seeing this theory carried a bit further forward, because nobody's ever observed what a primordial black hole might look like. But the argument that Joe Silk and his colleagues, he's the principal author of this work, a very, very eminent cosmologist, what he's saying is that rather than black holes and galaxies being formed in the reverse order there, galaxies are formed first, black holes inside them are formed afterwards. Rather than that, it's the other way round. But the subtlety is, and I'm going to quote Joe Silk here, we're arguing that black hole outflows, and by that he means the winds that we know that black holes generate when they're accreting material. You get these relativistic, that means very high speed, winds of material and radiation too, coming from the poles of the black hole. And by the poles, I mean direction perpendicular to the accretion disk, the disk of material surrounding it, where all the stuff's going in. So they're saying, we're arguing that black hole outflows crushed gas clouds, turning them into stars and greatly accelerating the star formation. Otherwise, it's very hard to understand where these bright galaxies came from, because they're typically smaller in the early universe. Why on earth should they be making stars so rapidly? So, so the idea is the black holes are driving this rapid star formation by these violent winds.
It's quite extraordinary because and as I said earlier, it tips all the previous theories upside down. So what they're basically saying is that the Big Bang happened, and very, very quickly after that, these huge black holes formed, and then they caused the stars to be created at a great number very quickly, which then formed the galaxies. Is that what we're saying?
Yeah, that's right. So
wow.
What a kind of counter argument you might throw at this is that, well, even with the James Webb Telescope, we can't see any evidence of these violent winds, the jets of material that are coming out of the black holes. But what Silk says is that they're too far away. In fact, to quote him, we can't quite see these violent winds or jets far, far away, but we know they must be present because we see many black holes early on in the universe. These enormous winds coming from the black holes crush nearby gas clouds, turn them into stars. That's the missing link that explains why these first galaxies are so much brighter than we expected. And the article that I've been reading about this, which is on the phys.org page, comments that the young universe, as seen by Joe Silk and his team, the young universe had two phases, in which the first phase was this kind of high-speed jets and outflows from the black holes, accelerating the star formation. But then in the second phase, the outflows slowed down. And so you've got another phase where the gas clouds are collapsing again, still forming stars, but he's actually pointing to magnetic storms in the supermassive black holes as being a cause for that. So you've got two distinct phases of star birth in the very, very early universe, and maybe that will account for why they are brighter than we expected them to be.
This again underlines how amazing the James Webb Space Telescope has been, because we've said all along, once it got up there, it would start opening up areas that we've been wondering about for a long time, and potentially coming up with answers. I suppose we should qualify this by saying this isn't absolute. They've got to do more work to prove
that's right.
the theory. Which they also have to do through the James Webb Space Telescope, but it is starting to look like they've come up with a new beginning to the universe, which is it's pretty astounding, isn't it? If it's true, that's a major achievement.
Yeah, absolutely. It's it'll be really interesting to see how the just how the astronomical community and the cosmology community takes this paper, how they react to it. It's only just come out. The paper, by the way, is Which Came First, Supermassive Black Holes or Galaxies? Insights from the JWST. There you go. I might... Sorry, go ahead, Andrew.
Yeah, I'm just saying, and they're saying supermassive black holes came first.
Yeah, that they are, yeah. One of the authors is somebody I know pretty well because I've worked in a collaboration with her, Rosie Wise. She was one of the leading members of the RAVE project that I was very deeply involved with in the first decade of this century. Rosie is not somebody who pulls things out of the air or anything. She has her feet very firmly on the ground in terms of the astrophysics and the physics that go into these things. So I think this is likely to be an important, or seen as a very important paper, maybe pivotal in its importance. But by the way, I'm not suggesting that Joe Silk, the lead author, is in any way doesn't have his feet on the ground. He certainly does too. It's just that I know Rosie a lot better, and yeah, I know what she's like. She's very, very thorough. Very thorough.
Well, it makes my next question mute, but I was going to ask how you feel about this theory. Do you think it has legs? But if they're as astute as you say, obviously it does.
Yeah, these are people with far bigger brains than mine, Andrew, and they're not ones to go off half cock or anything like that. They would have made sure that all their observations and theory tie up together.
Yeah, got the brains the size of a planet, by the sound of it.
Yep.
Yep. All right. If you want to read that story, and it's well worth reading, it is on the phys.org website. And it's just, it's quite mind blowing. And I know quite a few people who have sent us in questions will be really keen to read about that, because they've been saying this all along. Something else happened, and it looks like you were right.
Yeah.
This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Space Nuts.
Now, Fred, to another story that has applications or implications that could have a few people going, "Oh, are you kidding me? They're not going to do this, are they?" And that is, of course, we've heard of NASA. We've heard of SpaceX. They're working together, and they're going to try and send people back to the moon in the very near future. But SpaceX is working on something else that has got the military intrigued. Fred, what's happening here?
Yeah, it's as you've said, it's the SpaceX work on the next big thing, if I can put it that way, which has already had 2 test flights, none of which were successful. And the second one was nearly successful. It was basically during the separation of the first stage from the second stage that things went wrong. It's called Starship, and I should say that the organization SpaceX is planning a 3rd test flight. Actually, it might even be this month. It's going to be very soon, so we might be reporting on that at some point down the track. The other 2 last year ended in explosions. But what you've got with this ginormous spacecraft is something that can lift up to 115 tons to low Earth orbit. So, the real reason for this work being done is because of Elon Musk's vision to send people to Mars. That's why he's built this spacecraft. It's an enormous thing, Starship. And he's focused on getting people to Mars. NASA, meanwhile, is also focused on Starship, but that's because the upper stage of Starship is destined to be the landing vehicle to put astronauts on the moon for the Artemis 3 space mission. Which is, I think it's still scheduled for 2020. I think it's 2026 that it's slipped back to now. Yes, because it will. They need a large vehicle that will set down astronauts and equipment on the moon's surface. NASA has chosen SpaceX's Starship to do that. So that's the focus there. But what we're hearing about now, and this is another news item, once again, actually from phys.org, it is a news item that suggests that the US military, namely the Department of Defense with SE at the end rather than CE, which is what we have, there has been, they presented some work at the Space Mobility Conference held at the Orange County Convention Center. Apparently that was earlier this month. What the Defense Department wants to use it for is point-to-point cargo transfer on the Earth. So not necessarily, not necessarily humans, but at least getting, if you need to get a lot of kit from one place to another very quickly, you can do it in an hour if you've got a Starship at your disposal. So I might quote, actually, there's one of SpaceX's senior advisors, Gary Henry. He says, rocket cargo point to point is not the reason we're building Starship. We're building Starship to get to Mars. But what we're finding is it's a system we're putting together that has profound impacts for national security. And one of them just happens to be rocket point to point. which just means using a rocket to get from one place to another. So supplies, possibly, maybe troops one day down the track. But I believe that the Defense Department is very, very interested. In fact, we hear that they began looking at the idea 20 years ago. But because now we've got this spacecraft that is almost ready to go, I wouldn't mind betting that there's a good chance that the next test flight of Starship actually is completely successful. It's the way Elon Musk and his colleagues learn, by breaking things and working out what they need to do to stop them breaking. So
he breaks a lot of things.
He does, yeah. But there's an interesting quote here from somebody called Gregory Spangers, who's the chief scientist for the US Air Force Research Lab. And he says, envision a number of containers sitting in a warehouse down in Cape Canaveral. We go to an alert level, we pull them up, you start putting them on the rocket. At each successive alert level, your time to launch shrinks and shrinks and shrinks until we can get it down to 1 hour. And apparently, the teams that work with Spangers, they've already been making mock-ups of the cargo bay for Starship, trying to work out how you can do that. To me, the thing that is interesting about this, because we're all lovers, not fighters, in the world of astronomy. But, I think you could imagine this having enormous humanitarian benefits as well. If you had to get stuff in large quantities very quickly from one place on the Earth to the other, it would probably be a very good way of doing it if you could afford it. That's the thing. But that's the whole, the nub of the matter with Starship is that it's cheaper because it's all a matter of scale. The SpaceX's reusable Falcon 9 rockets have brought the cost down typically of getting something into orbit from $20,000 a kilogram to $2,000 a kilogram. That's a factor of 10. But Starship will bring it down even more. And so it's really very, very interesting to look at the kind of possibilities. In fact, the figure I've seen, and this is pounds rather than kilograms, $90 a pound to get into orbit. What's that per kilogram? 2.2 times 9 is about 20. Sorry, about 200 then. $200 per kilogram. So it's a tenth again. It's come down by another factor of 10. So
I think they're talking about it becoming even cheaper in the long term when they build these bigger rockets and have more of them operating, and they're talking about dropping the price to what about $18 a kilo, $20 a kilo, right. $9 a pound. Yeah, so like you said, but the point I'm getting at is that is equivalent to what it costs them now to transport this thing by plane. The military transports are about $20 a kilo. And so if they can do it in a rocket, the advantage is time. They do it in minutes to an hour rather than hours to days, which sometimes is the case with standard aircraft transport. We're basically talking suborbital flight, aren't we?
Well, that's right. Sorry, we didn't really make that point. Suborbital flight is what it's about. It's about putting the thing up into a parabolic trajectory, a ballistic trajectory, and bringing it down. With Starship, you'd have to bring it down in a pretty specialized spaceport because that's a very, very big machine. And it's not something you can just dump down anywhere. One way of doing it might be to have offshore platforms and things of that sort, Andrew, which is what, of course, they do with the Falcons. But just taking it one step further, this is also in the game plan of Virgin Galactic. They are very keen to use the Virgin Galactic, the mothership and spaceplane system, not just for up and down joy flights, which is kind of what it's doing at the moment, but to do suborbital flight that will take you from London to Sydney in about an hour or thereabouts, less than an hour.
That's just, yeah. How bad's the jet lag going to be then? Oh, my goodness.
I don't know. Yeah, it would be very interesting because, yes, yeah.
Well,
You
if
don't
you
have,
let's say you leave London at midday, it
yeah,
takes 1 hour to get to Australia. The time here would be, let me
depends. It
think,
might,
midday. It'd be
yeah, well,
about somewhere around midnight or 10 p.m. or something like that.
yeah, that's right. It depends on
So
the.
so you're wide awake. You've landed. There's no way you're going to go to bed.
That's true. That's true. You might have to
Yeah.
go into suspended animation or something like that.
Yeah,
But
maybe.
anyway, it is very, very interesting technology and something that I think we might see getting more of an emphasis down the track.
Oh, look, I think it's going to become stock standard in the future. I think this is just going to be normal. They're talking about it as a potential at the moment, but I think the time will come where we're just going to see rockets taking off every day for one reason or another. The other part to this story, though, and people were probably saying, oh, why is the military getting involved? Why do they have to do this? Well, they have to do this because there's another player in the mix, and that's China.
Indeed. Which is, and China is very much heading in the same direction, I guess, as the US in terms of its capabilities in space. It's got its own space station. It's landed several spacecraft on the moon. The first robotic spacecraft to be landed on the far side of the moon is Chinese, and so they will be doing the same kind of thing, maybe.
Well, I believe they are. I think they are working on this. This is part of their plan. So, the US would probably be very naive to just say, it'll never work. We won't do that because they'll get left behind. In fact, there are some that are saying China is very fast going to take over as the absolute superpower in space if other countries don't get the lead out. So, the race is on.
The race is on. That's right. It's their Long March series, which is really. They've got something called Long March 9, which I don't know too much about, I have to say, which is doing the same sort of thing because the idea is to reuse it, to make it reusable, which is the breakthrough. It occurred in 2015 when Elon Musk was the first one to make a relaunchable booster rocket. But now a lot of players in the space industry are working in the same direction. Jeff Bezos's company, Blue Origin, that's already doing that with their space tourism flights.
Yes, indeed, and this is all going to happen in years, not decades. This multiple multiple launches, multiple payloads being shot all over the world, probably not far away at all. So it shouldn't come as a surprise, but they've got to get the hardware working properly yet. They're still working on SpaceX and the Starship rockets, but they'll get it. They'll figure it out. I don't doubt that. All right. If you want to read that story, I believe that one's on phys.org as well. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Space Nuts.
Now, Fred, it is time to talk questions and answers from our audience. We've got a few text questions to go through today, and the first one comes from Nate. Now, this is a question we've had probably many times, but it's worth revisiting because you never know what we're going to learn. As we heard early on, things can change in the astronomical world at the flick of a switch on the James Webb Space Telescope. So Nate asked, 13.8 billion years ago, something happened. We know that whether it was a big bang, the big bounce, or a Big Mac, we know there was an event in a seemingly centralized location. My question is, if space is expanding, what is it expanding into or on? Even the singularity, if that's even correct, should have been residing in something, right? Thanks for making my evenings great. Every podcast is listened to the moment it is dropped, and I cherish each and every one. You two are fabulous and have been a part of our lives since day one. Have a great holiday. Oh, we're back. And I can't wait to hear your answer. It's an old chestnut, this one. What are we expanding into? Or although he goes, what could we be expanding on? That's an interesting angle.
Well, yes, it is. It's a nice additional way of putting it. So I think the problem is that we apply our common or garden everyday logic to problems of cosmology that don't necessarily work on those logical principles, like parallel lines never meeting and things like that, which is actually, it is logic, but it's geometrical logic of an unusual kind. So the observation that we can make, and I guess there's 2 or 3 of them that relate to this. We can observe that the universe is expanding because we've got this signature velocity distribution of galaxies, that the further away a galaxy you see, the faster it is moving away from you. And that's exactly what you will get from space that is expanding. We also know that as far as we can see, there isn't an edge to it. We can see a horizon, and that the easiest one to envisage is the cosmic microwave background radiation, where you're looking so far back in time when you look out into space that you're seeing the flash of the Big Bang, which is now stretched from light waves to radio waves, microwaves, by the expansion of the universe. So the likelihood is that the universe just goes on beyond that. And if we were, and there's nothing to suggest that's not the case, if we were somewhere else in the universe and looked out from our vantage point, which is different from where we are at the moment on our galaxy, if we're on somebody else's galaxy somewhere else, we would see the same thing. We'd see a cosmic microwave background radiation and lots of galaxies all expanding away from us. So the question about what's it expanding into, we don't even know whether that's a meaningful question, because it's actually compressing the thing into our own perception of space and time. Whereas there are possibilities, certainly in terms of the geometry of the universe, there are possibilities that might say, well, it doesn't have an edge. For example, if it's like the idea of, in fact, this is quite a good analogy, actually. If you think of your excuse me, perception of the universe reduced to 2 dimensions. Now, we normally think of 2 dimensions as being on a piece of paper, a flat surface, but it could equally well be on a curved surface like a balloon. So if you have your perception of space sitting on the surface of a balloon, it expands as you blow up the balloon. And yes, in that view that we've got, it is expanding into an additional dimension, which is the 3rd dimension of space. So maybe it will turn out that we will discover that there are hyperdimensional spaces within what we've been thinking of as the universe, but maybe the universe is just part of something much smaller. So if you thought, sorry, I'm rambling a bit here, Andrew, but we've got a universe that's got 3 dimensions of space and 1 of time. But if it was embedded in a 5th dimension or something, in the same way that the balloon is embedded in proper space, then it maybe is expanding into something else. That's a complex way of describing something quite simply, which is we don't really know. But we think there are possibilities. There are geometrical possibilities that would allow that to happen, for the universe not to have an edge and be expanding, but to be expanding perhaps in relation to something like an additional dimension. We haven't seen any evidence of extra dimensions yet in any sense. And that's one of the things
but there are some very astute people that do believe that may be a possibility.
Yeah. And that there are multiple universes as well. That's correct.
Yes, of course. And what's the other one I heard? That the universe is folding back on itself. That's another one I heard.
Bit like a pile of washing.
Yes. The universe is just a massive laundry.
Yeah.
Well, it is a rather dirty place, isn't it? I mean, it's just full of dust.
Absolutely dusty. Yeah.
Dust and gas and humans.
Just a mess. Yeah, that's right. Complete mess.
All right. Thank you, Nate. The answer is yes, it's expanding. It's expanding at an accelerating rate. And what it's expanding into, we do not know. Lee Stevenson has sent us a question. Hi, guys. I'm an avid listener since discovering your show around 6 months ago. You are funny and educational at the same time. Which one of us? Okay. It's a great show. My question is, how can we learn so much about Mars' interior from the InSight mission? I can't figure out how we got the knowledge we have from a single point of reference down to the estimated location of meteor impacts. This has been puzzling me for quite a while, and I hope you can explain and educate me. Best wishes, Lee, an Englishman in Sweden.
Nice.
It's not that big a hop from England to Sweden, so stop showing off.
Actually, I saw this question and meant to check it out. Because I've been ill for the past few days, I haven't really had time. But there is some, there's some very, very clever work that's been done by the InSight team, and I think it involves. Of course, like all seismology, most seismology, you've got a volcano or something that erupts, or there's something hits the ground, and you pick up by a network of seismographs or seismometers all over the planet. This is on Earth, of course. You pick up the echoes of that particular seismic event, whether it's a reflection off the core mantle boundary, or whether it's a refraction past the core. These are all things that you can pick up, but it's fairly easy to understand what's going on, that you can explore the inside of the Earth by having multiple sample points. And by that I mean, lots of seismographs all over. Well, on Mars, you don't have that. You've got one little lander InSight, which I think I'm right in saying is now defunct. Yes, they switched it off, didn't they, last year? It's got one sensor. So how do you know when you are listening to the seismic signal of a meteorite hitting Mars 13,000 kilometers away or something like that? And it's a very, very good question. Now, because I meant to look this up, I'm not going to give a definitive answer here, but we might take that down as a bit of homework, Andrew. But sure. I'm guessing it may be to do with the fact that seismic waves don't just come in one variety. There are, if I remember rightly, it's P waves and S waves. P waves, I think, are pressure waves, and S waves are shear waves, which is two different ways that the medium that this is being transmitted through vibrate. And it's akin to a shear wave would be a bit like a light wave, which is a transverse wave. That's what we call it in electromagnetic radiation. Whereas a P wave will be like a sound wave, because sound is transmitted by pressure variations in a medium. It's got to have a medium to transmit it. And I suspect that you can do things with those, like the kind of things that we do with fast radio bursts in astronomy, where you know that the longer wavelength signals are going to come slower than the shorter wavelength signals. In other words, the higher frequency signals are going to arrive first, and that's what causes that dispersion that lets you get the distance to something without actually knowing its redshift. You get the dispersion because as it transmits through what we think of as empty space, but is actually a lot of electrons being very excited. So you can pick up information by that. So I'm guessing it's something like that. But I
Right.
will look that up because that's such a good question. And as I said, I saw it and I thought, yes, I must do some research into that.
It's very clever science, though, that they can
Yes.
detect an impact so far away and actually isolate its
Well, that's
location.
right. That's the thing. Exactly the point of the
Yeah.
question. Yeah.
And InSight did go there with the intent of studying the interior of Mars. So it had equipment that was designed to pick up these kinds of activities. So
Indeed, yes.
that would go halfway to answering Lee's question, but we'll put it in the homework folder. And for the record, InSight's mission ended in December 2022, about 14 months ago.
Yeah.
Give or take. Yeah.
Thanks, Andrew.
Thank you, Lee. And to our final question for this episode from Wayne. Greetings, gentlemen. Long-time Patreon supporter. Thank you, Wayne. We appreciate it. First-time questioner, though. What kind of gravitational wave, if any, is generated by a supernova? Would these be detectable by LIGO? Love all the horrible dad jokes. Keep up the great work. I'm glad someone likes them. That's one.
I mean, we don't. So
they're actually hard to find. Some of them are so. Yeah. I mean, I've found thousands, but 99.9% of them are not airworthy.
You must have a different website from the one
I don't mean they're rude. They're just so terrible.
Oh yeah, so appalling. Yeah. Yeah.
A supernova, does it make a gravitational wave? And I suppose the question, if I can expand on it a bit, is are gravitational waves different according to what causes them?
Well, the answer to that is certainly yes. And you know, the things that we can measure with LIGO in terms of gravitational waves is the amplitude and frequency of the wave and the rate at which it decays or increases. In the case of merging neutron stars, what you get is this chirp where the signal, if you transfer it to audio, becomes whoop, because they're spinning around one another, and then when they actually merge, that's the chirp. That's when it goes up like that. But I think, once again, I'm sort of dragging out from the bottom of my memories of researching into this quite deeply a few years ago. What caused? Excuse me. I'll be better when I've started the new dose of antibiotics, Andrew. Yes. Which Marnie's just
it must, Fred, it must really tick you off.
I tell you, I've never been as ticked off as I was when I discovered what it was. Yeah, that's right. Yeah, that whatever bit me. Yeah, I'll refrain from showing you what it left behind.
Oh yeah, thank you, because we are on YouTube at the moment.
Yes, I know.
Don't want to get banned.
No, we don't get banned for showing horrible stuff. Anyway, so just going back to it. So to generate a gravitational wave, you've got to have an accelerating mass, and that's why neutron stars in orbit around one another do generate strong gravitational waves, because you've got two objects which are spinning around each other or revolving around each other, and that it basically constitutes an accelerating mass. Now, with a supernova, and in a sense, we don't know that much about these details, but supernovae, sort of generally speaking, are symmetrical. So you have an explosion, and you have stuff going out in all directions, which kind of cancels itself out. So you're not really generating a huge gravitational wave
signal. There's a supernova in the background.
I know there is. I'm trying to ignore him, actually, because he's just such a pain. Marnie sent me a cartoon this morning showing a little dog dressed in armor, with a sword in one hand and a shield in the other, and it said, "How small dogs think of themselves when
Yes.
when somebody rings the doorbell." That's exactly what he's like. It's exactly what he's like. He's still only a puppy. He's only 10 months old, so you've got to give him some, understanding. Maybe one day he won't do that anymore. Anyway,
Yes, he will.
he is definitely an accelerating mass when anybody comes to the door, and will probably generate his own gravitational wave, although it wouldn't be very strong. But just to carry this a little bit further, I have seen the question of whether a neutron star itself, which is often the end product of a supernova explosion, whether the neutron star that will be left behind, because it's rotating, whether that would generate a gravitational wave. But it's because it's only rotating, it's not a mass being accelerated, linearly. It wouldn't, unless it has mountains on it, and you and I have spoken before about these millimeter high mountains that supernovas, that neutron stars might have. So if it's got a few millimeter high mountains on it, then it will generate a gravitational wave. But to the best of my knowledge, nothing has yet been seen by LIGO or the other detectors that actually represents that. So great question there, from Wayne.
You might be interested to know, Fred, that Wayne is actually watching us on YouTube right now, and apparently, our YouTube listeners and viewers are pretty excited by the fact that Wayne's question happened to be served up right now. So that doesn't happen often. So that's really good.
Thanks for the question, and thanks for watching, Wayne. Sorry you haven't got a straight answer, but I'll once again have a look at the details. It's a while since I looked at all this stuff.
Very good. All right. Thank you, Wayne, and thanks for listening, and good to have you along live. And if you do have questions for us, remember, you can send them through via our website, spacenutspodcast.com or spacenuts.io, and click on the AMA link to send us a text or audio question, or just click on the purple thing on the right-hand side of the homepage to send us audio. As long as you've got a device with a microphone, you're all set, and tell us who you are and where you're from. We always like to know. And if you're watching us on YouTube, don't forget, I've got to do it again, don't forget to press the subscribe button below. They all do it, don't they, the people on YouTube? And don't forget to hit the subscribe button below. So there we go. I've just done it. And that brings us to the end of another program. Thank you so much, Fred.
Pleasure, Andrew. Good to talk again, and we'll speak again soon, I think.
We will indeed. Professor Fred Watson, astronomer at large, getting over his tick bite, and to Hugh in the studio, who just gets ticked off all the time. And from me, Andrew Dunkley, thanks so much for your company. Looking forward to joining you again on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.